In this video, we're going to look at the separation of variables, and we will also solve for a general solution as well as solving for the actual solution of these differential equations. In part A, it looks like in order to do our variable separation here, that a quick cross multiplying might do the trick. So we're going to have y dy is going to be equal to 2x dx. And then if we go ahead and integrate both sides, then we're going to get y squared over 2 equals 2, and then we're going to have x squared over 2 plus c. We can go ahead and cancel those 2's. And then notice that we do not have a point given to us for this solution curve to go through. Now we could go through and multiply everything by 2 to remove that 2 from the denominator if you want. And so that's going to be 2x squared plus another constant, and we can call that c sub 2 or just call it c. And then you would take the square root of both sides, so y would equal plus or minus the square root of 2x squared plus your variable or your constant value c. Or you could just leave it the way it is up here. Either is fine. Looking at part B, again, you would go through the same process here. It looks like we can move our y squared over and our dx over here. So we have dy over y squared equals dx. And then we're going to integrate, and that's going to be 1 over y squared dy equals the integral of dx. And so that's the integral of y to the negative 2 dy equals the integral of dx. And so here if we integrate this, that's going to be negative y to the negative 1 equals x, and then plus c. And then moving up here, that's the same thing as negative 1 over y equals x plus c. So to solve for this, we can just flip our sides over, or we can treat this as one whole quantity, and we can cross multiply here and here. So we have negative 1 over x plus c is equal to y. Okay, moving on to part C. Again, same idea here. We can move our dx up and move our y to the bottom over here. So we have dy over y equals x dx. We're going to integrate both sides. And when we do that, we're going to have the natural log, absolute value of y, equals x squared over 2 plus c. And again, if we want to solve for this, we're going to have y equals e raised to all of this other side, x squared over 2 plus c. And that would really be all for that one. All right, so for the next one, so this y prime here, that's the same thing as dy dx. So this term that we have here, this is going to be 4y dy dx. And I'm going to go ahead and add that over to the other side. So we have 3e to the x. Now I'm going to multiply that dx over. So I have 4y dy dx, or no dx there, sorry, equals 3e to the x dx. Now we're going to integrate both sides. Okay, now we are going to move out our constants and integrate. So I always move out that 4. And so that's going to be y squared over 2 equals, I'm going to move out my 3. And if I integrate e to the x, I get e to the x back plus c. I'm going to cancel out that 2. So I have 2y squared equals 3e to the x plus c. And you can either stop there or move your 2 over and do some square roots. Either one that you want to do is up to you. Okay, for our next problem, you're going to find the general solution here. And this one specifically wants you to go all the way out and say y equals. Some of these other ones did as well. But again, it's really, I'd rather us wait until we have a solution or a point for us to go through before we do all of that. All right, so starting off again, we have this, and let's go ahead and see if we can't get everything separated. So it looks like on one side we're going to have 3y squared dy, and then over on the other side we're going to have x squared plus 1 dx. That's what it looks like. And now we're going to integrate both sides. So 3y squared dy is going to be the integral x squared plus 1 dx. And so here we're going to have y cubed. If I can get my pen back to working. We have y cubed equals, and then over on the other side we're going to have x cubed over 3 plus x, and then plus c. And we can stop there, we can do the cube root. I'd rather us just stop there for these problems. All right, and then number 3, notice it wants us to find the solution, not the general solution, but the actual solution of the differential equation that satisfies the given given condition. So now we're going to have all the information that we need so that we can actually go all the way through and find our C value and be able to write the general or the particular solution. So for the very first part, we still need to separate and integrate. Notice this time our variables are x and t. And so we need to go ahead and move some things around here. So let's see. It looks like we can divide our e to the t over. So I have x dx dt equals 1 over e to the negative t. Because I divided that over. And so this 1 over e to the negative t, along with, I can go ahead and I can flip this over, can flip that over, and I can move dt up. So I'm going to have x dx equals e to the t dt. And so that clears up a lot of work because now we can integrate both sides. So now once we integrate, if we integrate x, we're going to get x squared over 2 equals, and if we integrate e to the t, we're going to get e to the t plus c. All right, now let's go up to our given point and keep in mind that x is a function of t. This is the same thing as saying x at t equals some number here. So whenever you're looking at these different values down through here, this value t is going to be 0, and then your x value that's inside the equation there, that is going to be your 1. So whenever you're plugging in this case, you're going to have 1, and then you've got that 2 there. So we're going to have 1 squared over 2 equals e to the 0 plus c. So that's going to be a half equals 1 plus c. So it looks like if we subtract that 1 over, c is negative 1/2. So we have our c value. So moving back down here, we have x squared over 2, we're right here, equals e raised to the t power, and then minus 1/2 because that's your c. All right, and so we need to solve this to say x equals, and so I'm going to multiply everything by 2. So that's 2 e to the t minus 1. And then we take the square root of both sides. Now we have to determine, is it positive or negative? And keep in mind, this has to go through. This is a solution curve going through that given point, so it has to be positive. So it's going to be positive 2 e to the t minus 1. So there's going to be your solution. All right, for our next problem, more of the same. We do need to separate. So if we're going to go through and separate, it looks like our y value needs to come over here to this side, and our dx needs to come back over to this side. So we're going to have y dy equals 1 plus x over x, and then dx. Now we have all of our variables separated. Let's go ahead and integrate. So we have y dy equals the integral, and then we've got a fraction here, so we're going to have to look at a couple of techniques that we know to integrate fractions. Now to integrate y, that means that we're going to have to go through and say, well, that's going to be our y squared over 2 equals, and then 1 plus x over x. Always check to see if the derivative of the bottom is the top, and here it's not. It's close, and it's close enough. We're probably going to have natural log in the answer, but it's not quite. So we're going to have to go through, and the other option we had was to divide up our fraction into 2 separate terms. Remember to only do that when you have one term in the denominator. If you've got more than one, don't do that. Now, if we integrate 1 over x, we do get natural log, absolute value of x, plus, and now we're going to integrate 1, which is going to give us just x, and then we're going to have plus c. And this is where you can stop. And, oh, nope, sorry, forgot, you've got your ordered pair. So, again, keep in mind, this is your x, this is your y. So let's come over to the side and see if we can't find c. So we're going to have negative 4 all squared over 2 equals natural log of the absolute value of 1, which is 1, plus 1 plus c. So that's going to give us 16 over 2, which is 8, equals 0 plus 1 plus c. So it looks like c is going to be 7. Okay, for number 5, we're going to go through the same thing. We need to go ahead and it looks like move our x over. So we have the square root of y, dy dx equals negative square root of x. Then I'm going to move my dx up. So I have the square root of y, dy dx. Oh, no, we moved our dx. Oops. Equals negative square root of x dx. Now we're going to integrate, and we're going to change that y to be y to the 1/2 dy equals negative. I'm going to move that to the outside, the integral of x to the 1/2 dx. And now we're going to integrate. So if we integrate this, we're going to add 1 to the exponent. So 1 plus 1/2, that's going to give me 3/2. So the front part is going to be the reciprocal, or 2/3, equals negative. And again, this side over here is going to look the same. And then plus c. Now we're going to go through and remember that number is your x, this is your y, and we're going to substitute in. So I'm going to have 2/3 times 4 raised to the 3/2 equals negative 2/3 times 1 raised to the 3/2. This is getting kind of messy looking, plus c. So move over a column. Looks like we're running out of room. So we're going to have 2/3 times 4 raised to the 3/2. That's going to be the square root of 4, which is 2, and then 2 to the 3rd is 8, equals, well, 1 raised to the 3/2 is still 1. 1 times negative 2/3 is negative 2/3 plus c. So that's going to be 16 over 3 equals negative 2 over 3 plus c. So 18/3 equals c. So 6 is c. So let's go back and put it back into our equation, which was right here. So that's going to be 2/3 y raised to the 3/2 equals negative 2/3 x to the 3/2 and then plus 6. And that's going to be your actual equation. Okay, now we're going to talk about separation of variables homework. So let's go see what our So if we go ahead and move 6x over, we have 5y dy dx equals, and then we have negative 6x. Is that okay? And then we're going to have 5y dy equals negative 6x dx. Now that we've separated, we're going to integrate 5y dy equals the integral of negative 6x dx. I'm going to move out the 5 and at the same time integrate y. So if I do that, that's going to be y squared over 2 equals, and then move out negative 6, and that's going to be x squared over 2. And then what have we got to add? Add your c. I would go ahead and cancel. Groovy so far. Alright, so let's go ahead and find c. We can go ahead and plug in, can't we? Yes. So we're going to plug in. Remember our 3 right here. What was that? Was it an x or a y? That was x. What was this one? Y. So you know what to go plug in. You have 5 times, that's going to be 2 squared over 2 equals 3x squared, but x is going to be 3 squared, isn't it? And then plus c. Can y'all solve from there that c is 37, isn't it? And so now you can go back and put together 5y squared over 2 equals 3x squared, and then plus c, but we found c to be 37. And I want y'all just to stop there for these problems. That's good. Alright, with number 2, again, you're going to have to go through separating variables. And so here, again, let's see, what are we going to do? We need to move y down here. It looks like dx needs to move up there, doesn't it? So let's do that. So I have dy over y equals dx over 2 root x. Is that okay? Now look at that for just a moment. Make sure. What do we do next? We have this separated, then we integrate. So now I'm going to integrate both sides. And so really I'm integrating 1 over y dy equals the integral of, well, this is 1 over 2 root x, isn't it? So really that's a half, and then that root x on bottom, isn't that the same thing as x raised to the negative 1/2? Do y'all remember all of that rewriting that we've had to do? Okay, now let's see, what's the integral of 1 over y? If the derivative of the bottom is the top? Natural log. What's the derivative of y? And just dy, isn't it? 1 dy. Is that what you have in the top? Sure it is. So this is going to be natural log, absolute value of y equals, I'm going to move my 1/2 out, and then right here if I integrate x to the negative 1/2, you're going to add 1 to your exponent, aren't you? So that's going to make that a positive 1/2, and if I divide by a half, that's like multiplying by a 2, isn't it? Is that okay? And then what else have I got to put? Plus c. Of course, those 2's are going to cancel. Here's your ordered pair that they've given you. X is 4, Y is 1. So let's go plug in. So you have natural log, the absolute value of 1, which is just 1. So natural log of 1 equals x to the 1/2. So that's going to be 4 to the 1/2. Love how these work out nice and neat. Plus c. What is natural log of 1? 1. Y'all sure? I'm not going to tell you here. 0. Natural log of 1 is 0. Equals. What is 4 raised to the 1/2 power? Why is it 2? Did you take half of 4? Square root of 4. So that's going to be 2 plus c. So what is the value of c? -2. Is that okay? So go back up to your equation, which would be sitting right here, and you fill in that c value. So the whole new equation, you have natural log, absolute value of y, equals x raised to the 1/2 plus c. Well, plus c is going to be -2, isn't it? And to make this say y equals, you're going to raise both sides to the e power. You're going to say e raised to the natural log, the absolute value of y, equals e to the x to the 1/2 minus 2. And all that e to the power does, e and natural log. What's the natural log of e? It's not just e. It's natural log of e. Close. It's just 1. They're inverses of each other. They knock each other out. And so right here, these are going to undo each other. So you're left with the absolute value of y, which is going to be just y, equals e raised to the square root of x if you want, or just the other, and then minus 2. And you can leave it just like this. At the moment, you're welcome to leave it at this. Either one. All right, let's move on to number 3. Okay, for number 3, very similar, same thing, separate, integrate. So let's separate these. Well, we need to get dx out of the denominator, so I'm going to have to multiply that over. So I get dy equals y plus 8. Notice they've put that together for us. They want us to keep that together. Dx. Ooh, how are we going to move y plus 8? Divide by y plus 8. So look at what we have here. Dy over y plus 8. If we're going to integrate that, isn't that just 1 over y plus 8 dy equals the integral of dx? Well, how do we integrate 1 over y plus 8? We have 2 terms in the bottom, so you can't divide it up. That's not going to work. So we talk about the derivative of the bottom being the top. What's the derivative of y plus 8? What's the derivative of y? 1 dy, right? What's the derivative of 8? 0. So what do I have in the numerator? A 1 dy, isn't it? So is the derivative of the bottom the top? Yes. So what do I put? So natural log absolute value y plus 8 equals. So again, when we integrate dx or 1 dx, that is just x. And what else do we need to put? Plus c. Is that okay? Any questions? Alrighty, what do we need to do now? Find c. We got to go back up and find c, don't we? Okay, so let's go plug in. What is x? 0. What is y? So let's go plug in. So this is going to be natural log absolute value of what? If I plug in 4? 12. So absolute value of 12 is just 12. Equals. What do I get on the other side? C. Well, they made that easy for us. What is C? Natural log of 12. And to finish this, we can go back up and plug in. So I have the natural log, absolute value of y plus 8 equals x plus natural log of 12. And natural log of absolute value of 12, well, 12 is positive, so you can just write 12 there. And you can stop there on that one. All right, what's our first step? Separate. All right. So what variable do I need to separate, or what term? Sorry. E to the x. So I'm going to leave negative y dy dx on one side. And then equals, and then I'm going to put negative e to the x to the other side. Y'all good with that? Yes? Thought somebody said no. All right, and then what are we going to do next? What have we got to move? Move it. Got to move dx. So negative y dy equals negative e to the x dx. Is that okay? Now what do we do? Now we got to integrate, don't we? So I'm going to have negative integral y dy. Is that okay? Just want to move out the negative this round. Groovy? Okay, so negative, that's going to be y squared over 2 equals negative e to the x, and then plus c. Y'all good with that? Have I lost anybody? I'm going to go plug in. X is 0. Y is 3. Alright, so let's go plug in. So we have negative 3 squared, so that's 9 over 2. Do y'all agree with that? Yeah? Alright, equals negative, what's e to the 0? 1, and then plus c. Is that okay?
Is that right? Is even 0 1?
Yeah.
Okay.
Yep. Oh yeah, we're too early in the game for me to aggravate y'all with wrong answers. But there is tomorrow. Alright, add 1 over. What is negative 9/2 plus 1? Negative 7/2 equals c. Did y'all get that for your C? Alright, and so now let's go find our equation, which is right there, isn't it? So negative y squared over 2 equals negative e to the x, and then plus c, which is going to be negative 7/2. And I bet we could drop a negative from every term, couldn't we? If we wanted to. You could do that. You can multiply everything by 2 if you wanted to. You can leave it like this, even better. Okay, and number 5, we're going to get dp on one side and dt on the other. So, when we're doing that, we already have this dp on one side, and so it looks like we're going to have to move this entire other term in order to get dt on the other side. So we're going to have dp equals negative k times p minus 65 dt. And so to get the p minus 65, we're going to have to divide both sides by p minus 65. And so now we have our variables separated. I believe we have dp over p minus 65, and that's going to be equal to negative k and then dt. And now we can go from there and integrate both sides. We have everything separated. And so I'm going to integrate, and I'm going to move that negative to the outside. This is going to be our natural log, absolute value, p minus 65 equals negative, and then if we integrate k, that's going to give us k squared. Oh, no, we're respect to t, so instead of integrating that and saying k squared, this is really going to be kt and then plus c, because we're respect to t. So we're going to just add our t down there like we would with x and some number. Alright, so we're going to stop there. Oh, no, we're not. We've got our ordered pair here. So when we go to plug in, we've got 0 and we've got 130. And so our 130, that's going to be our p value. And 0, that's going to be our time. So when we plug in, we're going to have natural log absolute value of 130 minus 65 equals negative k times t, and t is going to be 0, plus c. And so it looks like we're going to have the natural log of 65 is going to be c. And so going back up, we are going to have, from here's our equation, we're going to have the natural log of the absolute value of p minus 65 equals negative k times t plus, and instead of c, we're going to put the natural log of 65. And we're going to leave it just like that for right now. Okay, for number 6, we're going to do very similar, same thing. We're going to separate, and right now it looks like we just need to multiply over our x value. And so if we do that, get my pen working, we're going to have this dx multiplied over. So we get 2y dy equals x plus sine x. and then all of that multiplied to dx. And then we're going to integrate both sides. And so that's going to be 2y squared over 2 equals, and then we're going to have x squared over 2 plus, and if we integrate sine, we're going to get negative cosine. So I'm going to drop that plus sign and just leave that negative cosine x plus c. Now let's plug in our x and y value. So I'm going to also cancel out those 2's. So I'm going to have 1 equals, and plugging in 0 here, I'm going to have 0 minus cosine of 0, which is 1, plus c. So it looks like c is going to end up being 2. So putting all this back together, we're going to have y squared equals x squared over 2 minus cosine x, and then your plus c is going to be plus 2. Okay, moving on. All right, so we still have to separate, right? So what's our first move? You could multiply d theta over, couldn't we? Sure, let's go for it. So that leaves me with sine theta dy equals cosine theta d theta. Now what? Divide sine theta over. So just because it's not like the others, it doesn't mean all hell's going to freeze over. It's okay. So those are going to cancel. So I have dy equals cosine theta over sine theta. Now what? Integrate. We've separated, right? Integrate. Well, if we integrate dy, what do we get? Y equals, I'm going to integrate cosine over sine. And normally our brains freeze at this part, but it's a fraction. It's fancy fraction, right? But it's a fraction. So how do we do fractions? It's the derivative of the bottom and the top. What's the derivative of sine? We got sine, cosine, negative cosine, right? If we move down that chain, what are we doing? Isn't that the derivative if we move down? If we move up, what do we do? Integrate. So I'm at sine, right? I'm right here. I'm at sine. And if I do the derivative, I should get cosine. Do I get cosine? Yeah. So the derivative of the bottom is the top. Natural log, isn't it? So right here, natural log, absolute value of what? Sine. Plus what? Now, number 7, you are just finding a general solution here. So, finding that general solution, you are still going to have to separate and integrate. Now, notice dy is kind of all by itself. There's no other y's here, so I'm going to have to divide by divide by sine. and multiply by d theta. So we're going to have dy equals cosine theta over sine theta d theta. Now we're going to integrate both sides, and I'm just going to integrate up here with the problem itself. So we're going to have y equals, and this is going to be natural log, absolute value of sine theta, and then plus c. All right, so now moving on to the. So the first thing you're going to do is what? Separate. So whenever you separate, you do need to move over your dx. That definitely needs to be done. So you've got x squared, get that moved over, x squared minus 1 dy equals 2x over cosine y dx. And then, did y'all see to move x squared minus 1 down? Is that okay? Where did you move cosine y? Up. So you have cosine y dy equals, and then over on the other side, you're going to have 2x over x squared minus 1 dx. Is that okay? Got it? Now you're going to integrate both sides, aren't you? You've separated. Now integrate. If you integrate cosine y, again, SC negative S negative C, isn't it? So cosine y, you're right here at cosine. You're going to integrate, so which direction do you go? Up. So if I integrate cosine, what do I get? So you have sine of y equals, sine y equals, what do you get on the other side? Okay, think about the 5 problems that we've done that are fractions. You've got more than one term in the bottom, so you can't divide it up. So what's the derivative of x squared minus 1? 2x. Is that the numerator? So what should this be? There you go. Natural log, absolute value of x squared minus 1. If you don't put that absolute value, you are going to miss it. Yes? Yes, I would definitely. At this point right here, keep your parentheses. Once you've moved it down to the denominator, it's accepted that that is one term. One whole quantity has 2 terms, but so one quantity. No, it would still be the same. Okay, any other questions? Good questions. Just food for thought, to solve for y, you would have to have moved that sign over, and that's where you would have an inverse sign. Sign raised to the -1. Do y'all remember seeing that? Inverse sign, and then you would have all of this inside the parentheses.
Is that the same as dividing everything by sine?
It's saying sine of what angle gave me all of that. Hey, any questions? Next. This one was already done. It's one we did in class. Here we can move our dx over to the other side. And we had to do a lot of rearranging on it. And then we were able to go ahead and integrate both sides. And we did get our natural log. And so our general equation, we had sine of y equals the natural log of absolute value of x squared minus 1 plus c. Okay, number 9. Again, separating our variables, we need to separate dp and dt. So as far as dp, we're going to keep that on one side, and I'm going to move this over to the other side. So I have dp over dt is equal to b plus ap, and then we're going to move our dt up. So I'm going to put times dt. And so let's see. That one is going to be a little bit strange for this one. It looks like we've got, these are just extra variables. P needs to be moved back over here. So we're going to have to divide it back over. So that's going to be over b plus ap. And that's going to be equal to dt. Now we're ready to integrate both sides. And so on this side over here, when we do our derivative of the bottom is the top, well, this is going to go out to 0. And the derivative of AP is just going to be that A. And so that's the extra amount that we have. And we're going to balance that by canceling it out by saying, well, we've got too many of those. So we're going to say 1 over A. And then we're going to say, well, the rest of it balances out for sure. So we're going to have natural log absolute value of B plus AP, and then equals, and on the other side we're going to have T plus C. Don't worry too much about the integrals that look like this. You don't focus so much on that. I'd rather you focus on your cosines and sines and some of the other problems. Okay, number 10, write and solve a differential equation that models the following statement. The rate of change of Q with respect to X. So we can take that right there, the rate of change of Q with respect to X, and say, well, I know that means dq over dx is proportional to 45 minus x. So is proportional, now we don't know if it is inversely proportional or directly proportional, but we do know in proportions we have a constant rate of change, and that's k. So that constant of your change is going to be times 45 minus x. Alright, now we're going to go through and move our dx over to the other side. So when I do that, I have dq equals k times 45 minus x, and then I'm going to put my dx. And now let's go ahead and integrate both sides. And keep in mind you are integrating with respect to x. And so on this side over here, so this k is just going to be a constant there. And so you're going to have, let's see, the integral of q, well, that's just going to, or dq, that's just going to give you q equals, and that's going to be 45 k. So whenever you integrate that, you're really just going to get 45 k and then just an x because that's a variable, and then minus, and then over here if we have that, that's going to be kx squared over 2, and then plus c. Alright, so for these problems we're just going to focus on separating and integrating. So for this, we're going to move this to be dy equals x dx. Then we're going to integrate both sides. So we're going to have y equals x squared over 2 plus c. On part B, for this one, we are going to move our dx up. So we have dy equals y dx. Then we're going to divide both sides by y. And so now we've got 1 over y dy equals dx, and now we're ready to integrate both sides. So we're going to have natural log absolute value of y equals x plus c. You can stop there. Okay, in part C, very similar, separating our variables. We're going to move dx up here and y down here. So I have dy over y equals dx over x. And so now when we're going to integrate those, we're going to have the natural log of absolute value of y equals natural log absolute value of x, and then plus c. And then part D, very similar, same thing. So you're going to have y dy equals negative x dx. Integrate both sides, so we integrate here, we're going to have y squared over 2 equals negative x squared over 2 plus c. Okay, and these last two, you again are going to move everything around, but here we're going to move that over to the top there, so there's no reason to move k, it's just a constant sitting there. So we have dy equals, and really we've got k times 1 over x dx. And when you go to integrate this, you can really just move that k out. So going back and integrating here, you're going to have y equals k times, and that's going to be natural log absolute value of x, and then plus c. And then part F looks like about the same thing again. So separating, we get y dy equals x dx. And then we are going to integrate, so we have y squared over 2 equals x squared over 2, and then plus c.